Hello, my name is A. Joseph Dupre III. I'm a member of the Technical Product Management team within the Communications Solutions Group at Keysight Technologies. And today I'm going to talk about part 2 of our Resilient Architecture series, where we look at testing cloud infrastructure, cloud services, web services, and using that in an environment where we can get benchmarking and performance numbers to really understand what our service is capable of. If we're providing an application service that might have a variety of different traffic that needs to be serviced, then we want to understand what the true performance of that service is and how that service scales in the public cloud. So today we'll talk about benchmarking performance of web server based applications. And what we want to do is build upon part 1, where we built a series of tables to understand what our test tool was capable of. So we learned in the previous round that our Ixia IXLoad application performance test tool, which we'll use for this particular demonstration, was capable of generating a significant amount of traffic. We chose different instance types. We charted those out in a table very similar to this to determine how large of an instance type might make sense for generating traffic, because we might want to generate more traffic than what our actual service is capable of and really understand what the limitations on throughput, connection per second, concurrent users might be for our particular workload. So we measured that. We determined that we were going to use an IXLoad client and an IXLoad virtual load module within a virtual test appliance, which is called a VM1. And we're going to use the C4.4x large because that's a nice mid-range balance between performance and cost. And so we can use that. We can certainly scale out horizontally and add additional VM1s, additional virtual test appliances if we need to generate more and more aggregate traffic. But for today's demonstration, we only need to generate a small amount of traffic because we're going to use a small web server instance size. But we want to be able to generate and show how you would go about constructing a table for your particular use case, your particular workload. And so I'm going to choose the C4 family as the target of what I'm going to generate traffic to. So I've got a C4.4x large acting as a client on the Ixia side, generating application traffic. In this case, we'll see it's encrypted traffic. And we want to destine that now, instead of to another Ixia test appliance, to an actual live server in the Amazon cloud. And we're going to choose to build a table by running repeated traffic using a similar configuration and then just changing our web instance type. We want to keep the same web configuration, all of that stuff intact, but we want to go down the rows here and kind of figure out, what are the trade-offs in terms of performance. We have these ratings from Amazon: moderate, high, 10 gigabits per second. What is our actual perceived traffic when we run our particular workload, our specific encrypted traffic with our ciphers and keys? And what do we see here? We want to build a table that kind of shows, is it worth going to the next size scaling vertically, or is it better maybe to have a lot of smaller instance sizes? Certainly when we move on later on in the series to auto scale groups, elastic load balancers, you're typically going to want to make that service more resilient. So you're typically going to want to find that ideal instance size and then scale that horizontally. And so really figuring out, when does something like a compute intensive workload really require the next level of doubling, and when are you not going to see a significant jump? For an increased price, are you really getting the best bang for your dollar, or is it better to right size that, perhaps pick one level smaller, and again scale horizontally when you need to, if and when you need to, right? So first of all, we got to break this down. We've isolated the test tool. We know what its performance capabilities. We've picked an instance type that is more than capable of generating enough traffic for this case. We're now going to pick, for the demo, the smallest instance in this size in this table, and we're going to run an example test, and you would just scale that up. Now, if we did this all manually, it'd take too long. It'd be more complex. We might make a mistake. We're humans. So we, of course, want to always back this up with automation, and we want to make this table really easy to generate. We can certainly automate the IXIA configuration by having a consistent RxF file, an IXLoad configuration file format, where we can just change the number of load modules that we use to generate the traffic and increase our objective and do it that way. So that's one thing we can do. On the other side, we want to be able to create, in this case, one instance of a web server. Later on, we'll want to make many of them. And so by having a CloudFormation template where we can define the parameters and automate those is the best way to do that. It's very easy to take a CloudFormation template and then basically codify all the details of your configuration, including the web server configuration. You might have some startup scripts that initialize the web server, and you can make that all embedded in your template, and then all you have to do is choose instance size differences. So in this case, I chose instance sizes that happen to be, here's a C4.large, but with the CloudFormation template, I can quickly redeploy or modify the configuration and scale that up or down and run these repeated tests. So I've got the IXIA on one side, I've got the web server. Let's actually check out that web server and see it's out there. So if it's running right now, I've got a client and a traffic generator right here ready to go. We'll go into that in a moment. But what I'm going to do is I'm just going to go and kind of show you there's a web server out there. It has the DNS that is assigned to it by Amazon, and I'm going directly to that web server. It happens to be an Apache web server at the moment, but maybe another web server code base like Nginx might be more appropriate for your workload. That might be something you're trying to figure out, like what is the best workflow. You know the advantages and disadvantages of different web server technologies, but you're trying to figure out, okay, in generalities, I understand that. Specifically to my workflow and my workload, does one or both make sense? Where might I use one in one set of scenarios and another? But how can I really quantify that that information? And so I just want to validate that I've got an EFS mount point here. And let's see if there's like a test page there. So I'm testing from some EFS Elastic File System. So I've got a front-end web server that's front-ending basically an Elastic File Store where I serve my files. That'll be useful later on when we go to autoscale. But for now, I just want to check some pages here and basically see that we basically have a corpus file that we use when we're doing IXIA to IXIA testing. So we've loaded that up on the web server, and I might have, it's 1024K. EFS mount point slash. So we got that one. There should be another. And there it goes. Probably just fat fingered it a little bit. But just wanted to show you that that web server is out there and it's serving pages, including our test corpus file that we can use to validate the actual performance. So what I'm going to do now is I'm going to move over to remote desktop into the IXLoad client. We've got the single port that's been configured for the IXIA virtual test appliance that's going to be used to generate our traffic. We have the configuration for that traffic, which is HTTP, but it's a client, but it's actually an encrypted client. So we're going to do a get SSL to the location of that web server. So that should match up there. So we're going in this case for this demo directly to the web server itself. So we can get those numbers for the single web server. And let's take a look at some of the things that we're doing in the settings here. It is SSL based, and we are using, in this case, an AES 128 SHA 256 for our cipher combo here. And remember that we saw in the last blog round that things like AES-NI, right? The instruction hardware sets for AES encryption by Intel, for instance, can have a significant impact on our traffic. It can make those virtual machines, instead of being very slow with just virtualization only, when they're hardware assisted by technologies like that, or SRIOV, single root IO virtualization. Those are things that basically give cloud VMs more significant throughput capability, performance capability to serve more and more users, and that applies here as well. So we saw that when we were, figuring out what the sizes are for our test tool. That's also going to apply for getting the best performance possible out of the actual web server. So we can pick an instance that has some of those functionalities, and we'll see better results than we would if those feature sets, like the instruction set for AES, were turned off. Okay, so that's basically all set up. We've got an objective. This is a smaller instance size, so I've set it to 600 megabits per second, and we're really looking for, we can push these instance types sometimes higher, particularly if you have something like a burstable instance type like a T2, but we're really looking to understand kind of what's our baseline, what's the steady state, what's a nice square wave of throughput, so we kind of understand what's our worst case scenario. If this particular workload is sustained for long periods of time, heavy duration, kind of really taxing the web server in this case, what's that going to look like? Can we get really an understanding of what that real good steady state is, where we're confident that this is kind of a top limit that we're conservatively comfortable with for that particular instance type, and that's where we might make the decision point to scale horizontally at that point, right? We've kind of pushed that. We may even want to put in some buffer, for what percentage, below our kind of maximum point for our workload do we want to, put in some buffer, and we'll see that when we kind of move to auto scaling. What's the right level of tuning? We can figure this out for a single web server. When we start getting a larger amount of them, what's the nice kind of happy medium in terms of when we're getting the most value and when it makes sense to scale up. So we can't really understand that until we break down the single web server, debug and understand its workflow, make sure it's serving things properly, figure out any issues with our environment that might need to be involved. We also want to understand the cost. We're going to be generating traffic. If we're using things like public IPs, there's going to be a cost involved in working with that, right? We're going to be generating traffic in and out of the Amazon cloud, AWS, and there's going to be in cases where there's that traffic may be quite significant, gigabits worth of traffic, and we want to understand what those costs are. So by running these types of scenarios, these simulations, and configuring the Ixia tool or any other traffic tool that we want to use, like a breaking point, will allow us to really understand what our workflow looks like, how our servers handle it. Is there anything we have to fix on the web server code base, any patches or anything else we need to do that might optimize performance? Perhaps we need to shift it to another instance type, but we can really see what that looks like, and the more square our square wave is, the more confident we can be that we can really sustain that load for a period of time. So that's what I kind of wanted to show you. You can certainly read more about it in the blog itself, part 2, and you can subscribe to and monitor our blog page at ixiacom.com. You can also, I encourage you to, if you want to get more detail on how to build and construct a configuration like this, run in the cloud, get more details on how to deploy that test CloudFormation template to get your test tool into the cloud, I recommend that you subscribe to our Ixia Training TV channel on YouTube, and ring the bell so you can get alerted when this and other videos are posted. That's it in a nutshell. Thank you for watching. Have a great day.